All right, an engineer designs a hydraulic jack to lift 4,560 kilograms. Okay, if the output cylinder is 8.20 centimeters in diameter and the input is small, okay, so this is a situation where we've got a tiny input cylinder, right? Then we have an output cylinder that's somewhat bigger. So here's our input cylinder, our output cylinder, right? So we're lifting, and what we do here, by the way, is we just go pressure equals pressure. Pascal's principle is that the pressure inside a fluid is everywhere the same, okay? This is, hydrostatic pressure notwithstanding, okay? So we're going to go force 1 over area 1 equals force 2 over area 2. And the kind, pressure is force divided by area. So we're just saying pressure here equals pressure there, okay? So we've got typically a jack has a small input cylinder if we're trying to increase the force and a big output cylinder, right? Okay. So we want our output force 2 is going to be 4560 times 9.81. So let's figure that out, right? Because we got to lift up this. That's the weight of that object. 4560 times 9.81. And that is 44,733.6 newtons is our force 2, right? Okay. And then let's see, we've got output cylinder, it's centimeters, it's diameter, right? So this is 4.1 centimeters is our radius, right? Okay. And let's see. And then let's see, 0.42 centimeters. So this is going to be, that's diameter, right? So 0.21 centimeters is our radius. Okay. So we're going to go force 1 divided by area 1. Right? And that's going to be force 1 is what we're trying to find, right? The input force. Here's force 1 here, right? This is force 2. Which is this, right, is equal to force 1, and then the area is pi times, let's see, and this is our input cylinder, right, so it's 0.0021 squared, okay, that is 0.21 divided by 100, right, because I'm going to square meters, right. By the way, you don't have to do this, you don't even have to do diameter, right? You don't even have to do radius. You can just do diameter squared. But anyway, all right. I'm gonna go with the way we're supposed to do it. And then our force 2, right? On this side, we've got force 2 over area 2. Force 2 is 44,733.6 newtons, right? And our area 2 is pi times what is this? 4.1. So it's 0.041 squared, right? And that is 4.1 divided by 100 is what I put in there, right? That's what we put there. All right. I think we can do this. So I'm going to take this number on my calculator. Notice that the pi goes away. So this number on my calculator divided by 0.041 squared times this number squared. 0.0021 squared. All right. And now I get that F1 is 117.4 newtons. Ta-da! Now, when you get to this point, right, notice that we divided both diameters in half. We multiplied them both by pi. Since these things always have an area on both sides in the denominator, really you can just, in the denominator, just go, force divided by diameter squared, force divided by diameter squared. It works, right? But, what the heck. All right.